Okay, so first of all, what is a differential equation? It's an equation that has different derivatives in it. Something like, let's say f prime plus f double prime plus 3 times the function equals 10. This is an example of a differential equation in which we have the first derivative, the second derivative, and the function, and that's an equation. Okay. Now, we are going to look at only two types. There are many types. There are several types. I shouldn't say many, but several types of differential equations. We're going to look only at two types. One type, just simple. It's called simple. Differential equation, DE. Simple differential equation. The other one is something called separable. Very simple, simple ones, and separable DEs. Okay, so let's start first of all with a simple problem, just a warm-up. I'm on page, which page am I on? I'm on page 535. And I would like to start with a very simple example. Let's say problem 3 on that page. So we are given y prime equals e to 4x minus x plus 2. They're telling us that we're told that y of 0 equals 4. And the problem says find the general solution. And then find the particular solution. This is something called initial condition. Well, we know how to do this. We're just integrating both sides, or just finding the antiderivative. So then in order to find y, what function prime is this, what function prime is this, what function prime is this, plus a constant c. Can anyone help? What function prime is e to 4x?
E to 4x over 4.
Excellent. Minus
X squared over 2.
Very good.
Plus 2x.
That's it. This is the most general, right? But now they also want, so this is part A, and in part B, they're asking us to find that particular one. No problem. I plug in 0 everywhere, and the result has to be 4. So then 4 equals. When I plug 0 in here, how much is this? 1/4. Very good. And when I plug in 0, this is gone. When I plug in 0, this is gone. When I plug in 0, that's plus c. So c will be 4 minus 1/4. So c equals 4 minus 1/4. The least common denominator is 4. 16 minus 1, 15. So 15/4. So that particular solution will be I will write it in a moment. E to 4x over 4 minus x squared over 2 plus 2x plus 15/4. This is the general solution. And that will be a particular solution based on the initial condition. Any questions? Any questions before I write it? Are we okay with this? This is nothing different from what we've covered so far.
So basically for this, for part A, you just do your antiderivative.
Exactly.
Like and then just solve for C for the
Exactly. Yes. Given the initial condition, I find a particular solution corresponding to the initial condition. Correct. Is this okay? Any questions? Okay, so then I'm going to write the solution, which is the particular solution for the given condition, initial condition. So that would be y equals e to the 4x over 4 minus x squared over 2 plus 2x plus 15 over 4. This is the particular solution that they're asking us to present based on the given condition. Okay, this is one type of problems. This is nothing different from what we covered before. But here is another that I would like to work on, like number 9. Show that y equals x natural log x minus 5x plus 7. Show that this is a solution of y double prime minus 1 over x equals 0. This is a differential equation. It has derivatives in it. If it has derivatives in it, it's a differential equation. So they're telling us, show that this is one of the solutions. What do you think we need to do here? They're asking us to find that this is a solution. And normally, what do we do when we want to show that something is a solution of an equation?
Wouldn't we eventually set it equal to each other?
Well, so
or plug it in.
Exactly. That's the first answer. Excellent. Yes, we have to plug it in. But let's see what we plug in and how I plug in. Very good. Awesome. What do I have to find? Looking at the differential equation, I will say, oh, I know what I have to find. I have to find what? I don't have it. I have the function, but I don't have the second derivative. This differential equation only has the second derivative minus whatever they are giving us, and we need to show that this is 0. So, okay, I have to find y double prime. But I can jump from y to y double prime. What do I have to find first?
Y prime.
Of course. Very good. Awesome. Careful now, because many of you missed this situation. This is a product rule on the test. 1 times 2. This is not the product rule. This is not the product rule, right? This is simple. But here I have to use the product rule. First, I differentiate the first function. I get 1 times natural log x plus. I keep the first function, and I differentiate the second one. Anyone remembers natural log prime is? I know you know.
1 over x.
Excellent. When I differentiate negative 5x, I get negative 5. When I differentiate 7, I don't get anything. Very nice. So this goes away. So it will be 1. This is not 0. 1 minus 5. So then y prime equals natural log x minus 4. Good, but not good enough. I need to get to the second derivative. So can anyone give us the second derivative of the function? In other words, the first derivative of this.
One over x.
Excellent. Look what happens now. How much is 1 over x minus 1 over x? Would you say that this is a solution of the given differential equation?
Yes.
So, very good. So, y is a solution of the given, differential equation. Still very easy, very clear. Let's work on one more. Okay, let's look at 11. Any questions for me? Any questions? Any questions? So this is 11 on the same page. So they're telling us y double prime minus 2y prime plus y, they say this is 0. Show that y equals negative 2e to the x plus x e to the x, same question, is a solution of the given differential equation. Show that it's a solution. How do I start? What do I need to do?
Find the derivative of y.
Yes, to put it here. And after that, find this, to put it here. This is given. I have it. But I don't have this piece, and I don't have this piece. So can anyone help with y prime?
2y dx.
Very good. So negative 2 e to the x plus, be very careful, this is the product rule. Function 1, function 2. Function 1 prime is 1 plus function 1 times function 2 prime. I have to combine like terms. So this is negative e to the x plus x e to the x. So what I have so far is this piece, but I need this piece now. Can anyone help with the second derivative? Right? This is still negative e to the x. There is nothing we can do here. But here, again, I have the product rule. The function times another function. First function prime is 1 times the second function plus the first function times the second function prime. So the answer is x e to the x. So now I have all pieces. I have the preps done. All I have to do is plug them in. If I don't get 0, then I will say, sorry, this is not a solution of the differential equation. But if I do get 0, when I plug those in and simplify and I get 0, then I say, yes, this is a solution of this differential equation. So let's try. This piece is replaced by x e to the x minus 2. This, parentheses, better, safer to put parentheses first. Negative e to the x plus x e to the x. Close. Now I reached plus y. I have to copy this as is. Since it's plus, I copy negative 2, no need of parentheses, plus x e to the x. I do not write 0 because I don't know. I need to calculate. Okay. So for now I see x e to the x plus x e to the x. That's 2x e to the x. Negative 2 times negative e to the x is positive 2e to the x. Negative 2 times x times e to the x will be negative 2x, x e to the x. And minus 2e to the x. So this with this are here. Then this is here, and I have to copy this. And now let's look carefully and see what we have. I have a 2x e to the x, but a negative 2x e to the x. Thank you very much. I have a 2e to the x, but a negative 2x to the x. Thank you very much. So since the answer is indeed 0, as I was hoping for, I will come back to the function and say, yes, it is a solution. I checked. I determined all pieces. I put everything together. I simplify step by step everything, and it turns out that I got exactly what I was supposed to. Since I got 0, I go back to the function and say, yep, it works. It is a solution of the given equation. Any questions on this?